Chapter 11, Fluid Mechanics. So basically, Chapter 11 has to do with the physics of fluids, and fluids include both air and water. Some of the main important concepts that we're going to be talking about are buoyancy, liquids and gases, pressure, the units of pascals, density, and three principles: Pascal's principle, Archimedes' principle, and Bernoulli's principle. I'll tell you the important points to write down, but the place where this lives online is Chapter 11 under our website on fluid mechanics. This is the slideshow here, and I'll embed this lecture right below it. So if you want to refer to our lecture today that's being recorded, you can do that and look at it online. Before we really get into it, though, we want to review Chapter 3 and two important things that we covered in Chapter 3. In addition to density, we covered Boyle's law. Boyle's law says that when the pressure of a fluid at a constant temperature is increased, the volume of that fluid decreases. Now, you don't have to write this down. And it also says that when the pressure is decreased, the volume increases. Okay? And we also learned in Chapter 3 Charles's law. Charles's law says that when the temperature of a fluid increases at constant pressure, its volume also increases. And conversely to that, it says that when the temperature decreases, the volume also decreases. So there's four important points in Chapter 3 that you'll need to keep in mind when we move through Chapter 11. Pay attention. Okay, here we go. Chapter 11. Pressure. Pressure is a pressing force, a push. Write that down. Write that down on your notes. Pressure depends on the amount of area over which it is exerted. Write that down. Pressure depends on the amount of area over which it is exerted. If the pressure is exerted over a small area, like if you take a needle and you press it on your palm of your hand, the area of the tip of the needle is very small, and the pressure is great. If you use the same amount of force and you're pushing, say, a hammer, the head of a hammer on your palm, the force is going to be less because it's spread out over the large area of the hammerhead compared to the point of the needle. We can find a formula for pressure in pressure equals force divided by area. Bullet point 3. Pressure equals force divided by area. And I would like you to add this to your circle formula sheet, page 2 on the back. Number 8 on your circle formula sheet, pressure, force, and area. And here's what we'll do for that. Let's write this down. We're going to use P, F, and A. P is equal to pressure. F is equal to force, measured in newtons. And A is area. And meters squared is the unit for that. Newtons is the unit for that. And the new unit for this is PA, or pascals. And we'll get into that in just a second. So our circle formula is going to look something like this. Let's translate what it just told us right here, where it says pressure is equal to force divided by area. We know how to translate that linearly as pressure equals force divided by area. Can anybody tell me from that what's the one thing that we need to know and where does it go? Sophia? F is on top. Good. So if F is there, P is there, and A is there. This P and the A are interchangeable, by the way. That, of course, means times. This line right here means divide. Yes, ma'am.
Are we going to have to know all these
I want you to be familiar with them, and I would like you to know which ones are on top. The only thing, not the only thing, but I'd like you to know how to use the circle formula, of course, and I would like you to know which ones are on top for those relationships. Yeah. Okay, so that's the circle formula for pressure, force, and area. And as I mentioned, the units are newtons over meters squared, force over area. Newtons over meters squared is given a special unit of its own, which is called pascals. Bullet point 5, write that down. Pascals is newtons divided by meters squared. So pounds per square inch is also, or atmospheres. Remember that in chapter 3 we talked about the force of the air column above every square inch on our body. We said that it's equal to 14.7 pounds per square inch. And so it's also measured in atmosphere. It's also measured in millimeters of mercury. That's another measure of pressure. Okay? It's really important for you to know that P equals F over A. Pressure is force divided by area. And we'll do some word problems with that in the coming week. Okay? Any questions on this? ATM is atmospheres, and atmospheres is measured in pounds per square inch.